Alright, good morning everybody. I'm going to explain today the physics midterm 1, the problem number 1. So, you have that the pelican is falling with an initial velocity this way. This is the x component and the y component, and this is the vector of the initial velocity. So wait, this is not very good representation. Alright, so you know that this angle makes 20 degrees. So if you say sine of theta equals the x component of the initial velocity over the hypotenuse, which is the initial velocity. And this, as was stated in the problem, has a value of 15 meters per second. So when you solve for Vx, this will give you 15 times sine of 20 equals Vx initial. And by the same way, to determine this side right here, we do cosine theta equals V initial in y over Vi. So this is equal to 15 cosine theta. The part A of the question asks us to give them the initial velocity of the pelican. So in code we can represent it like this: pelican dot bell equals vector, to represent that this is a vector of the first, the x component, which is this one, 15 sine of 20, then the y component, which is this one, 15 cosine 20, and then in the c component there's no value. Now let's do part B. Part B asks us to give them all the necessary code to update the position of the pelican. So we know that there's weight and force drag acting with the movement of the belly of the pelican. So let's calculate W first, which is weight. And this is weight, as you know, is gravity times mass. So you say minus gravity, which is already given in the code, that is 9.8, times pelican dot mass times j hat, which previously we should have stated that j hat is equal to 0,1,0. This one because it's representing that's going downward in the vertical axis. So we have weight. Now let's calculate the magnitude of the pelican's velocity, and we will call it bell.mag. This is equal to magnitude. This is an already called function in Python, converts any value into a magnitude, and pelican.velocity, which is a vector. So this is converting the vector of the velocity into the magnitude. Now we say bell.hat is equal to pelican.velocity over the magnitude of the pelican's velocity. Recall that a vector is equal to the multiplication of its magnitude times the hat. So we are converting this into code. Now let's calculate the force of drag, which is the constant b, and as it was stated in the problem, they say that when they dive through water, they experience a drag force proportional to their speed cubed. So we are going to represent this in code by saying bell.mag times bell.mag times bell.mag. Now this is its velocity cubed times the constant of drag force. This will give us the drag force but in a magnitude, and we want it as a vector so that we can add it to the weight, which is also in vector, and we multiply it at velocity hat. Now we say that force net is equal to weight plus force drag, and they are both vectors, so they have no problem in adding each other. Now, to represent the way the pelican velocity is altered in code, we say pelican.bell equals the initial velocity, which is pelican.bell also, plus the force net over the mass of the pelican, which is pelican.mass times delta t. Now, since we have the pelican.velocity, we can write down the code for the change in the position of the pelican, which is the question. Pelican.pos equals pelican.pos. Recall that the initial velocity, that the initial position is the vector 0, 0, 0, which is also given in the problem, plus pelican.bell, which is this value over here, which you calculated previously, times delta t. Now this is all the procedure you have to do to calculate the new position of the pelican in code. My name is Ricardo Gonzalez, and I hope you learned how to solve this problem as I did by thinking it through slowly and steadily. Thank you.